All right, this is just a video to demonstrate how to find the direction of induced current in this ring for the example of flux through moving coils. So this is kind of a funky representation, but basically what I've drawn here is just a side view of these two rings. So the side view of this ring is just a line because there's no current in it. And for this ring, we have current that is coming out of the page at the top of the ring and into the page at the bottom of the ring. So we use our right-hand rule to determine that this means the magnetic field is going to be going to the right. So near this loop, we're going to have a B field that is going in this direction. All right, so in order to determine what the flux is through this ring, we're going to just denote the direction of each of these things. So the B field is to the right. And it's going to be convenient for this conversation for the flux to be positive. So just as in the previous example, we choose for the dA vector to be directed in the same way as the magnetic field, which is also to the right. So you can imagine that after some time, the rings begin to draw closer to one another, just as in the example statement. And as they get closer, the magnetic field is actually stronger through this ring because the magnetic field near this loop of current is strongest closer to the loop. And so we could imagine that the magnetic field is getting bigger, which means the flux is also getting bigger. So I'll just write that right here. The magnetic flux through this ring is increasing during this motion. So in order to determine the direction of the induced current in this loop, we know that the induced current will create a B field whose corresponding flux would oppose the change in flux. Since the change in flux is positive, which just comes from the fact that the flux is increasing, we know that the induced current is going to create a magnetic field whose corresponding flux is negative. So we can refer back to this simple equation for the flux and see that the induced current is going to create a magnetic field that's pointing to the left in order to create the negative flux, since the dA vector is pointing to the right. So in order for this magnetic field to be pointing to the left, we know that the induced current is going to be coming out of the page on the bottom of the ring and into the page at the top of the ring. So we represent that in this way. And that's pretty much it.